Right, so let's kick off this introduction to data analytics. I'll just introduce myself first. So I'm Shaheed. That's slightly old photo. I still look like that, but maybe slightly older. Um, I'm Shaheed. I work as a consultant, working on a big project at an insurer here in London. We're delivering a data platform, so hence the data strategy bit. I've completed a master's in data science, and I've been teaching at General Assembly since 2019. I've taught many courses, including part-time data analytics, as well as full-time boot camps. So I have a lot of experience, happy to answer any of your questions that you might have about the course or just generally about working in the field. So who are we at General Assembly? A leading training provider of technology training. We train and connect diverse tech talent directly to employees. After starting as a co-working space in 2011 for entrepreneurs in New York, they decided to create a peer-to-peer mentorship as well as classes and workshops, and this led to General Assembly, which has helped over 16,000 graduates start a new career in tech. I've personally seen people go from, somebody was a chef and they completed our boot camp and got a job as a data analyst. So it's definitely possible to do career change, and it's never too late. I would say learning something is very valuable, and we can help you with that. So what can you learn at General Assembly? So these are the four sort of main areas: engineering and development. So that's like software engineering, so actual like hardcore coding, product and UX. So that's creating new products, product management, and designing great user experiences. Data and AI. This is the area I work in. So that's data analytics, which you could call like reactive analytics, or AI machine learning, which you could call um, pro, predictive analytics. Sorry, I just saw Simon's message, so that's why I paused. Okay, so everybody else seems okay. Simon, hopefully you can sort your sound out. Thanks. So before we get started, some quick reminders. This is just a beginner level overview of data analysis. There'll be time for some questions at the end. Just you've already all started to post in Google Chat, so just make sure you can. So happy for you to send questions there, anything, comments, send reactions, whatever you feel like. Happy, please use the chat as much as you need. So what we'll learn today, we'll go through a definition of data. We'll show you quickly how to navigate around Excel, still an important tool in the world of work, mainly. We'll quickly dive into asking questions of your data and how to think about that in a good way. We'll also look at a data analytics workflow that will help you kind of understand how you might be able to apply data analytics to any problem. And then at the end, we'll have a survey and Q&A. So let's dive in. So what exactly is data? Maybe you can type in the chat some definitions that you might have come across. I'd be happy to hear. I'll give you 30 seconds to do that. Someone says informations. I like that. That's a good start. Any others? Yeah, we're getting there. Collection of information is great. Uh, Reactions of your customers is some type of data. Yeah, great. The gold of the future. I like that. I think, yeah, I think you hit on something there, Kisoro, gold of the future. Brilliant. So thanks for that. So let's look at some examples. So you can look at data like this. So what this is Seamless is a company, and they have posted these adverts all over New York. Maybe I can't remember who, but who lives there might have seen them. Maybe they're a little bit old now, but essentially they've taken their customers' habits and made some fun posters about the data. So Gramercy Park has the most potassium-rich neighborhood, meaning they eat the most bananas. So this is a great example of using data to showcase certain things about your customers. Um, I'll show you another example. Spotify, which gives you music, but also collects a load of data from their customers. Um, some of you probably subscribe. They send you that your year in music at the end of every year, which is kind of like taking your data and presenting it to you. It's a bit of fun. Maybe there isn't too much, value you could derive, but it's a bit of fun. But um, that's kind of examples of data that you see in everyday life, and actually you'll see it in advertising, in government broadcasts, in the newspapers. We just see data being presented to us everywhere. I'd even say, like, reading newspapers, you probably need some sort of data literacy to actually understand, especially like economic presentations. And so even if you don't work in data, I think it's quite important to be able to interpret data and what they mean. So I think quite a few of you got this definition quite closely. Data is information that exists in a variety of formats. Um, so it could be features about you, like your name, age, and job, or it could be some descriptive of you, like your hobbies. Um, all kinds of things can be data. And let's look at a data example, maybe like a typical, you sign up for a service at a company. They would generally try and well, these days you kind of like forced to share your email address with loads of companies. They all want your data. They all want to know who you are. And this is like a typical example of that, where we have somebody called Greg Hansen and some information about Greg Hansen, um, an ID, the city they live in, the state they live in, the segment that they fall into in your business. So this is an example of like a furniture business of some sort, maybe like a technology and office supplies business, or something along those lines. And then Alyssa Krause is another person. And when you take that data and you put it in a table format, like at the bottom here, that is like typical of what you might see when you start working in data. So when you open your first Excel spreadsheet, something like this would be presented to you, where what we call this is like data in tabular format. So tabular meaning table, table meaning rows and columns. And if you've used Excel ever, you would have noticed that it's sort of made as a rows and columns, and therefore anything you create a block of data with that's what we call a table. Now, tabular data is maybe like more traditional. That's sort of where you would think a lot of more the older way we think about data fell into. But since maybe, I'm not sure since when, but as like the internet exploded, there's been a lot more collecting of what we call unstructured data. So unstructured data is like sentences and words, and we all use ChatGPT or some sort of AI these days, and that's what that sort of technology has been trained on. So, you know, there's a lot to data now. This is like a simple basics of data. So say you had these type of information recorded about someone: age, height, weight, birthday, name, and nationality. These like represents what we call data types. Data types being so in Excel there isn't like a strict enforcement of data types. It sort of lets you do whatever. But when you start working with databases like a SQL database, if you've ever heard that term, but a SQL database is where most companies store their information. And in a SQL database, there'll be like data types. So data types mean when you look at age, height, and weight, those are all numbers. And so we store them as a number. And that allows you to sort of define how you can operate on them. So, for example, numbers you can add up, you can subtract, you can divide, you can do all those kind of things with numbers. Your birthday is a date, and a date is a different data type in Excel, but also just generally in the data world, which means you can do different kinds of operations on them, and they get stored differently in the back end of your computer. So the guts of the computer stores these things in different ways. And your name and nationality are what we call text or strings. Strings is like the technical term for that. So a string just means a text value. So my name is not a number, it's not a date. It's just something that is a text, and it therefore works in a different way. And that's why when you think about these different data types, it allows you to do different things, and that's quite an important kind of concept that's worth learning when you start working with data. I'm happy to take questions as we go along. So if you have any comments or questions, please put them in the chat. I have that up on my screen. So what does a data analyst do? Quite a broad question, because data analysts do all kinds of things. Bridget, yes, I think we've already shared it, a link right at the start of the chat. But if you scroll up, you should see it. If not, I'll ask Naz to drop it again. Okay, yeah, brilliant. So what does a data analyst do? Brilliant. Yeah, we'll share it again. So data analysts work to interpret data and bring meaningful and actionable insights. So I think let's just break that down. So you have a load of data. The data analyst's job is really to look at that data, analyze it, interpret it, communicate that to stakeholders, whoever is in charge of making decisions. So let's think of an example. Somebody is trying to sell more furniture. So use our furniture example, and they want to know what, like a strategy that would help them do that. So you as a data analyst, you have access to all the sales of a company, and so you can perhaps analyze that data. Actually, you'll notice that people tend to buy more in the first week of the month, so maybe we can offer discounts in the first week of the month to make that even better, something along those lines. So the decision was to actually offer a discount, and the data analyst's job is to bring that to the fore and actually communicate actions that can be taken to answer a question. So that is the data analyst job in a nutshell. So the toolkit that data analysts use, this is like a typical toolkit, I would say. So Excel and Google Sheets are sort of your first point of call, let's say, if you start a job as a data analyst, but even not as a data analyst, just generally in most corporate environments, you're going to have Microsoft Office installed or Google Sheets, and information will be stored in these types of documents. But maybe not everybody's doing analysis, but Excel is a very powerful tool. I would say it's still my, I mean, I've worked now for 20 years, but my first job, I did everything in Excel. We didn't have any other tools, and I would use Excel and VBA to come up with really novel solutions to problems that we had in our company. Um, Salome, yeah, is Google Sheets as strong as MS Excel? I think it is, generally, and it's really great for sharing. I would say that most like bigger corporates are using Microsoft. Not all, but most. And so it's very similar. You don't really need to worry if you only know one or the other. I think you can pick up the other one. So if you are at home and you need to use a good sort of spreadsheet tool, Google Sheets is free and you can run it in your browser. Excel, you kind of have to pay. So, use Sheets if you need to. And Excel, I think you'll pick up if you know Sheets. So yes and yes, but companies generally use Microsoft products. Could you please advise the course to learn Python from the beginning? I think best to explore the General Assembly website. There's definitely courses available there for beginner Python. And shouldn't AI tools be on this list as well? Bertrand, that's a great question. It is. It's a funny one because I would say yes. Nowadays, probably most people are using some sort of AI tool to help with their work. But to me, if you want to understand how to analyze data, you still need to know how to use these tools. And AI is mainly helped as a supplementary to help you maybe code better in SQL or code better in Python. I think I wouldn't necessarily include it in the list because it's a very general tool. So it's not only specific to data analytics. People use it for word processing. People use it for all kinds of things. But it's a fair point, I would say. Tableau and SQL definitely run on MacBooks, no problem. SQL, you generally need to use a specific type of technology. At General Assembly, we use open source called PostgreSQL. In companies, I mean, currently I use Snowflake, but in previous companies we've used Microsoft SQL. It just depends where you end up, but MacBooks are no problem. It's Google Sheets. Andrew, great question. I think it generally is. I think it's not 100%, like everything necessarily won't necessarily work, but 98%, let's say. And Google Sheets have some cool kind of extra functionality, I would say. You have like a function that allows you to do translation directly in your spreadsheet. So no, it has a few like extra bits that Microsoft Excel doesn't have. So worth exploring if you want. Yeah, no problem. Shout with any other questions. I would mention Tableau is what's called a visualization tool. And what that means is it's sort of visualize first rather than looking at like in Excel, you kind of look at the numbers, you look at the table, and then you create your plots, whereas Tableau and the other sort of major player in this space is Power BI, which is Microsoft product, which is actually what I use currently at my office, but they sort of the same. Um, based visualization first, which what that means is you drag and drop and then it creates a chart. It's really good. Is Tableau free? Tableau Public is free. So if you search for what's called Tableau Public, it is a free version of the software, which allows you to use Tableau. It does require you to set up an online account and sort of post to your public profile. But to be honest, that's what I use at home if I need to, because I don't have a license. So it's very good. Tableau Public, it's called. Yeah, Maya, that's a really good point. And Abir, yes, the recording I believe will be available to you later. I'll just mention SQL. So I have mentioned it already, but this is a really, really important tool. And I would say if you're going to work in data analytics, you need to know SQL without a doubt. Like you could possibly get away with not knowing Tableau, for example, but SQL is the one that everybody uses. Why? It's where all the company's information is stored. So even in today's world where we talk about cloud computing, and cloud computing means everything's stored in the cloud, that still uses SQL as a language to access the data. So I would say that SQL is the one you should definitely learn first as like a coding language. If you've never coded, it's really easy and satisfying to actually learn. So especially the basics is very easy to pick up the basics. To get to a really intermediate level, I would say it's quite forgiving. So I'd encourage you to try and do that. And then what's not on the list, but we do teach in our longer boot camps is Python. And Python is super powerful. Obviously, it's used for all kinds of development. So, but there is a specific sort of Python toolkit for actually doing data analysis, and that's what we teach in the boot camp. You'll learn things like pandas and NumPy and how to use some of the machine learning libraries. So very powerful. Truthfully, I don't use this at work, but I know some people do. So it's sort of like a tool that can be used or not, and it's almost a choice, and depends also on your sort of your company that you end up in, what their toolkit is. And so if like programming is your thing, I would definitely look at using Python. Open queue. So Maria has raised a hand. I don't know if you can talk, but if you type your question in the chat, I'm happy to answer. So who has used Excel to any extent? Yeah, some people, Bridget. Okay. Kasora says daily. Great. So a lot of you've already old school. I agree. Old school, but still powerful. Thomas loves Excel. Cool. So to you guys, this is like just to show you what Excel is, and so it'll be really, really introductory. I would highlight that Excel is still like a tool that people use. I mean, I work with a finance department at the moment, and especially in like a finance department, everything they do is built on Excel. And what we're trying to do actually, like in the data strategy world, is sort of bring them to the modern world. And so what that means is using Snowflake, using Power BI, and actually starting to think about using data in a more modern way. But Excel is still like the lifeblood of companies. So don't knock it. And I like the enthusiasm you all have for it so far. So this is like super introductory. Essentially, when you open Excel, it'll show you, do you want to use a blank workbook? And that's standard in any Microsoft product. And as I said, this is quite basic, but for those who don't know, it'll look something like this, and there's a ribbon which allows you to do a lot of operations. And if you've used any type of Microsoft product, it's very sort of familiar. And so when you graduate to, say, Power BI, it'll be the same. It'll look like this with a ribbon on top, and it allows you to do things that you can do in the software. What have you used Excel for? I'd love to hear in the chat if you can share. Um, when we talk about Excel, this part of the screen is where you have your data, and that's where you can perform operations on your data and do all kinds of things. So that's called a cell, and a cell holds some data, and as I mentioned earlier, it's made of a row and a column. So row and a column kind of defines a cell, and that allows you to do operations. And if you select many cells, that's a range, and you can create a table and do all kinds of things. So we're not going to get into that. We only have a short time. So this is just really to show you what Excel is rather than what it can do. And, when I was using Excel on a daily basis, I would say I didn't really use the mouse too much because it's much quicker. Once you get really quick, you tend to use keyboard shortcuts. So these are some of the examples. I won't go through them all, but in the slides, there's a link to some more. If you're interested, especially if you use Excel daily, it's really good. It makes you faster, makes you more efficient. So it's really cool to learn. I'll just check out what you guys have said about using Excel. So Bridget uses it for financial data. Somebody uses it for project management. It's really good for that. Some Elizabeth, you visualize some data, some historic analysis, export agile data. Bridget is tricky to keep the formula updated. Yeah, so those are the kinds of things we'll teach you in our course where you become more efficient because there's certain things you do need to know to be able to do things in an efficient way and actually become quite good. Function as a calculation, track budget. So these are all like everything you can do in Excel, and Excel is, as I say, a super useful tool that still, I don't think Excel will ever die. I think Excel will be around in 30 years. I think it'll still be there. So, important skill to learn. And even with, we had a chat about AI, you still need to be able to, know what you're doing. Even with AI, you can't just trust the AI to do things for you. You need to know what you're doing. Even if it does all the technical stuff for you, you still need to be able to interpret the data. So I think these skills don't disappear. They might sort of change a little bit where you need to be a bit one level up. You don't do all the technical stuff, but you do the interpreting. You need to like dive into the data to understand any issues. I don't think all that work disappears. It's still there. So, you know, I I tend to disagree with the whole AI is going to steal all our jobs in the future. I think it'll just change a bit. Would be happy to hear your opinions on that. If you have any, put it in the chat. Okay, so yeah, I agree with that, Dave. You become maybe like a cyborg. um, agree. Another new tool, which is a really fun tool and can do some fun, like really, really cool stuff. But I think you do treat it like a new tool. Cool. So let's dive into the data analytics workflow. And this is a general assembly workflow we teach. It's not like something you'll find necessarily when you join a company. But what it does is it allows you to it allows you to structure your work in a way that makes it a lot more efficient to deliver good work. And so we teach this as a way of structuring your work so you don't get lost along the way, because the sort of the temptation when you start with any data analysis is to dive into the data and start like answering random questions, which has its place. It's called exploratory data analysis. That has its place when you don't know what you kind of trying to answer. But when you generally working for a company, they might ask you to have a project where you're trying to answer specific things, like say you're working on a marketing project, you need to answer specific questions about the furniture business that you work in. So this workflow helps you structure your work so you don't sort of drift off and do random things that might not be useful. Um, what the best way to run through it is by going through each step. So first thing to note is this is not a one, it's not a process you go around and stop and communicate. It's a iterative process. What that means is you kind of might start at framing, but at analyze you might realize your question that you asked didn't really tie up with what the business needed, so you go back and frame your question again. But let me just run through the steps, and then we can talk about that. So the first step is to frame your questions for your analysis. So that's important because you don't want to really answer questions that are irrelevant to your business. So what that means is working with your stakeholders to understand their point of view, what's the type of decisions they're trying to make. So we'll go through an example after this of how to kind of ask the right questions, and hopefully that'll sort of illuminate what that means. But essentially, you don't want to be answering questions that doesn't help the business, and that's quite important. You want to be doing useful work as a data analyst. Once you have your questions, though, so say you've sorted out what questions the business want answered and what kind of decisions they want to make off that question, then you can find the data that generally will live either in your SQL databases of your sales system, for example, or maybe you work in financial services like me and it's on Bloomberg, or maybe you do some, you working on a specific industry and there's some publicly available data on the web and you can scrape that, or there's some APIs which are ways of accessing data, and we teach all that in our course, like the different places you can find data. So once you have the data, I think in any type of data you get, you're going to have to prepare this data. And what that means is really getting it into the shape that allows you to create good analysis. So sometimes data is in the wrong shape. Sometimes like a number is formatted wrong. Maybe there's a typos and things like that that you have to kind of fix before you can make useful analysis. And this is this step, I think you'll see sort of like jokes or memes on the internet which talk about how much time actual data analysts and data scientists actually spend doing preparation of data is 75-80% versus the actual analysis. So this is a very important step, because it's sort of like the garbage in garbage out type of thing, where if you don't get it cleaned you can't really create proper conclusions. It's a very important step, and everybody who works in data will end up spending time doing that. The next step is to analyze your data. So what we mean here is to actually, once you've cleaned it, actually like start looking at charts, like somebody mentioned charts, looking at tables, looking at trends, looking at some statistical tests like averages, medians, all those kind of things. And that is that's like the meat of what you're trying to do. Although probably you spend more time on the wrangling, this is what you really want to be doing. You want to be creating charts, answering the questions that you created in framing. once you've done that, you want to interpret that. So that means actually like interpreting it into trying to make a decision. So I found that the office desks are bought more regularly during the summer when offices are more empty, and therefore offices kind of do more renovations. So perhaps we can put on a promotion to take advantage of that. That's just an example. That's the kind of like thinking you want to do as a data analyst. You're not just like looking at data. You want to actually like recommend decisions based on your analysis. And then finally, there's this communicate phase, and the communicate phase is like presenting it. So as analysts, we do a lot of like dashboards. Dashboards are ways of summarizing data, which allows like users to actually like interact with it, use filters and things like that. You've all used the dashboard in your life because I think so. You've opened your bank account app, for example. It presents you with your account. You can click and then you see your transactions. That is like a dashboard. But in the company setting, it'll be like sales or marketing or whatever context that you're working in. You might write reports, you might just present some charts, all kinds of communication is very important, and being able to talk to your stakeholders is very important. As I said, this is like an iterative process. You don't just sort of follow it like that. You kind of do the steps, go back, frame your question. In all this, you want to do useful work. Yeah. So as I said in our course, we will we'll use this as a way of structuring your work. I'll share near the end like a Tableau public link to some of my students' work, which will show you like the kinds of things that they did in the class, and then you can you can see how that kind of materializes. So that first step in that workflow is really framing the question. So what we really want to do is answer useful questions. And the problem is that sometimes, like management, they have an idea of what they want, but they don't really ask the right questions. So the example on the slide, what insights about returns can be gained from the Superstore dataset. So the Superstore dataset is a dataset we use, which is actually released by Tableau, and so it's used by a lot of sort of companies for learning. And it's a really rich dataset about a shop that sort of sells furniture, technology, those kind of things. And so that's a very vague question. What insights can be gained from the data set? So what we really want to know is a bit lower down than that. So for example, somebody might ask you like a really specific question, like what's the average sale amount for a type of product? So that's like a really specific question. You can go in the data and you can just answer it. Another example, is our profit trending up or down over the last few years? Very specific question, which you can find an answer for quite easily with like some Excel or SQL skills. Um, but sometimes you might like get a vague question, like tell us about our Facebook page performance. Give us insights into our inventory. These are really vague questions that sort of they don't have a really easy way to answer. So our job is to really like drill into that with our stakeholder, our boss, and actually like understand what they're trying to answer. So let's look at an example. Are there any patterns in shipping preferences? So that's like a stakeholder type question, but perhaps we could be much more specific, and what we call a hypothesis is something you can test and answer with a yes or no. That's really what a hypothesis is. It's used a lot in like statistical testing, but we can use it in data analysis.
Stop card is this.
I'm sorry, somebody talking? I can hear something. No, okay. If you have a question, do type it in the chat. Happy to answer. So what's a hypothesis? A hypothesis is when you you can answer that with a yes or no. Like, is it true or is it not true? So shipping preferences is how they ship the product. So if we looked at ship mode, we may discover that certain ship modes are more consistently used than others. So maybe if it's like air shipping or marine shipping, for example, it's a random example, but people use air shipping more often. So let's actually drop the other one and actually use the one that is used more consistently. That's the kind of thinking we want to get into. And I'm not going to read all these, but essentially you can look at this in the slides. So this is like a stakeholder type question, and this is a much more specific way of like phrasing it into hypothesis. A hypothesis is a statement which you can test with the data, and once you test with the data, you can say, is that true? Is that not? And then you can kind of make a decision based on that. Hopefully that makes sense. I'll just go through the last one. So which ship days have higher discounts on their orders? So if we looked at the days that are shipped and compared to the order days, for example, the number of days between shipped and order, that some days have an average higher discount than others. So it's kind of like writing it in a way. You can answer it with the data, and then it makes it easier to frame, to work in that way. So hopefully that makes sense. Do shout with yeah, great question. Great name, SSB adjusters. Why is it better to use hypothesis? Because you can answer it. The reason why it's better is because you can say whether it's true or false, and it makes it testable. In other words, there isn't like ambiguity once you have hypothesis, and that's the reason why we prefer it to do that. Whereas if you answer just a question, you might not be able to say, is that true? And you can't really necessarily make a decision because you'd need some more answers. Rayan, yeah, great question. So we don't go into that, but one of the other things is to make the question like something measurable. So when we say measurable is, as you say, put a target on it. So the questions should be like measurable. So obviously in our example, yeah, we don't go into too much detail, but exactly, you should really make something measurable so that you're able to actually answer it like that. We do hypothesis-driven entrepreneurship. Um, I'm not sure I have here heard the term, Bridget, but I assume that it's a similar kind of concept where you actually test something out. Is it true? Is it not? Therefore, is it failing or is it passing? And therefore you can kind of do it. And it's a similar concept. So we want to kind of make it a lot easier to make decisions. And that's why you draw things in this way. Okay, so the next stage in your workflow is really the extract and wrangle prepare phases, and like I said earlier, this is really probably going to take you the most time when you're doing any analysis, but it's not necessarily the most the meat of what you're trying to do. That comes later when you're doing the analyze, interpret, communicate. But this part of any data analysis project is really important because it sets the foundation for getting everything right later on. So yeah, we're doing things like, I don't know, people who've used Excel, maybe you've used a lookup function like a VLOOKUP, or these days there's something like an XLOOKUP, and that allows you to like join two tables up and look for information in one table that's in another table. And so you do things like that, and that's probably like one of the first things that we teach you is how to look up data in another table. But other things like your date is in the wrong format. I need to change the format of the date. I need to so I have an address which I want to split up into town, city, country. Those kind of things are what we call wrangling the data. And wrangling the data is where, like I say, you'll spend most of your time. In a course, the boot camp that I taught, we use real world examples. So we look at like Airbnb data. So it's quite messy, like the address and like the list of amenities. So we need to like split that out. There's like a project on gender pay gap, which has like some messy data because it's like a government website data, freely available. So there's lots of like things like that, and you'll learn how to do it in Excel, but actually you need to learn how to do this in all the tools that you use. So you can use Excel for wrangling, but it sort of slows down when there's too much data. So you want to really like move to SQL because that's where the data lives. And so you can do your wrangling in SQL, for example, or actually if I'm using Tableau, I might use Python to actually do my wrangling and then create a file which is ready for Tableau. I like that workflow. That's sort of my preferred way of doing it. I'm a big fan of Tableau software for visualization, but in terms of like working with the nitty-gritty of the data, probably something like Python, even Excel is actually better. Has anybody done anything sort of like a data analysis project where they've had to wrangle data? Love to hear about that. I'm just gonna put a link in the chat with like a project link for some of the work that people have done. So this is on Tableau Public. You can see like people's projects, which is really cool. And so you'll see lots of different, like there's thousands on there. I would encourage you to have a look. These are just like nice projects that I've seen students work on, and so I thought it's really nice to share with you. I'll share one more. Yeah, I'll find it and then share it with you. This one. Okay. Yeah, these are just like really nice projects. So what you need to do if you want to use Tableau is download Tableau Public desktop app, and then you can do your own Tableau work. Yeah, great point, Dave. That's exactly like the types of things that you end up doing in the wrangling phase. So you want to like clean your data so that it's easily analyzable and interpretable. Yeah, and have a look at those Tableau projects. I think it'll show you like what people can achieve in a few months after starting off as beginners. So that's what I have. You're awesome. You've got skills to learn and places to go. So as I said, happy to answer any other questions. We do have some do have something for you. This is a QR code, which gives you a discount on a workshop before 31st August. So please do go and use that. That's on the in the slides also. So have a look if you don't get the QR code now. And I think your feedback form was shared on the chat. So please do fill that out. We love to hear your feedback on the session today. Any comments and questions, please. Now's your time. I know you've asked lots of questions, but happy to answer more. This is just a QR code to the same feedback form. Leah says, "Wow." I guess Leah saying "wow" because of maybe the Tableau Public projects that I shared. Do you need to download Tableau for the workshop? No, you don't need to download Tableau for the workshop. That's just a suggestion if you want to play around with it. How do you get back to the recording? I'm not 100% sure, but I think Naz or T will reply to that one. Rayan says, how can we advance our data analytics and will AI replace this work? I think my opinion is AI might replace some of the sort of easily automatable work. So what I mean by that is sort of taking the data, perhaps some of the cleaning that that you need to do, those kind of wrangling, maybe that'll become easier. So maybe you won't spend as much time on that phase of the workflow. But I think that analyzing, interpreting, communicating, these don't change. This is the bread and butter of the data analyst. So that's really where I see the work being. But to know how to actually analyze data is really important. So I wouldn't like outsource that to an AI. I would want to understand how that works. It's kind of like if you go study maths at university, they're not going to give you the answer like through a computer, which is always possible. They're going to teach you the theorem from scratch. So same with data analytics. The best way to advance your data analytics is to practice. So what I would do is, get some data. There's a website called Kaggle. It has loads of data. I'll just type it in the chat here. That's got lots of free data. You can just find a topic that interests you, start looking at it in Excel, use Google Sheets if you don't have Excel, because that's free and everybody can use it, and just start analyzing, start trying to answer questions. That's what I would say. I mean, the other option is to take a course and do some like practical work, but I think that is the best option, is to do some work on data. Yeah, pleasure, everyone. Happy to have shared this with you.